So here's our goal. We're going to do something a little bit more complicated than printing out secret values. I actually have a very targeted goal. Specifically, I want to write a target number, which I've chosen to be 100, to a target address, which I've chosen to be dead beef. That's what I chose. You could choose something else. Maybe the thing you want to write is, I don't know, address of shellcode. And maybe the address you want to write to is address of RIP. Who knows? But you can write any number you want to any target address you want using the attack that we're about to show you. So I chose 100 in dead beef somewhat arbitrarily, but you can actually use this to write whatever value you want anywhere you want. So that's the setup of this question. We have this piece of code, and we drew a stack diagram for it. While we're executing printf, it keeps track of these arguments on the stack, and it knows if I ever see a % formatter, I have to match it up with the next unused argument on the stack and print that value out, or write to that address, or something like that. And my overall goal as the attacker is to provide something in buff that will write 100, the number 100, to the address dead beef. That's the setup. Any thoughts on the setup? OK. So with our setup all ready to go, we are now ready to start thinking about how to write 100 to dead beef. So we already know there's going to be a %n in there. %n is what lets me write values to memory. But this is the point where things get kind of tricky, because a lot of different things have to be true at the same time for this attack to work. So I kind of think of this attack like juggling. So in juggling, you have to get all the balls in the air at the same time, or you have to put all these different things in the right place. And sometimes getting them all in the right place at the same time can be tricky. And so when you craft these exploits, it's often the case that you make one thing correct, and then something else is broken. So you go to fix that thing, and it breaks 2 other things. And you go fix those things, and it breaks another thing. And you fix that too, and it breaks another thing. So it can take a little bit of trial and error. And sometimes when you break one thing, you have to fix it, and then it causes more things to break. And after lots of breaking and fixing, you need everything to line up in a very specific way so that the target value gets written to the target address. So that's what we are about to see. We're going to try to get printf to line up everything in the right place. So we already know there's going to be a %n, because %n is how you write things into memory. And my goal is to write something. And when the %n occurs, remember, printf reads the 0th argument letter by letter, and anytime it sees a %, it replaces it with something or writes something into memory. When printf goes letter by letter and it sees the %n, I need 2 things to be true at the same time. And this is where the juggling comes in, because you might get one of these but break the other, and when you fix that, you might break the other one. But we need both of these to be true at the same time. When %n appears in the printf output, the next unused argument should be this address, because what will printf do? Printf sees the %n, and it thinks, oh, it's a %n. I better go on the stack, take the next unused argument, and use that as an address and go to that address and write stuff. So when the %n occurs, whatever argument is the next unused one, it might be arg4, it might be arg6, it might be arg7. Whichever one it is, I need to make sure that the value dead beef is sitting there in memory so that the %n sees the value dead beef, goes to that address, and attempts to write there. So that's one thing that has to be true. This is controlling where we write. If I mess this up, printf might write 100, but it might write it to the wrong place. So we have to get this right so that when printf goes on the stack, takes the next unused argument, happens to be dead beef, I go there and I write some data. And what data do I write? Well, hopefully the number 100. And remember, how does printf know what value to write? It thinks about the number of bytes printed so far. So the second thing that has to be true at the same time, and that's what makes these exploits so tricky, is that the number of bytes printed so far has to be exactly 100. So printf will think, how many bytes have I printed so far? 100 bytes? OK, great. Then what I will do is I'll go to dead beef, and I'll write the number 100. So at the same time, I have to juggle the fact that I need 100 bytes printed and the fact that when printf sees %n, the next unused argument on the stack, wherever it is, just so happens to contain the value dead beef. And all of this has to go into my printf input to buff. So that's the juggling that has to happen. So we're going to make this happen.